Hello everyone, hope you're having a fantastic day. Today in this video we are going to be working through another example of calculating the derivative of a function using the chain rule. And so at this example I have a function f of x equals e to the power of sine cubed of 2x squared times secant cubed of 2x squared. I'm going to start out by breaking this apart by using the product rule and first finding the derivative of e to the sine cubed of 2x squared, and then secondly finding the derivative of secant cubed of 2x squared. By the product rule, we can find the derivative of the function f by taking the derivative of the first component, e to the power of sine cubed 2x squared, the derivative of that times the second component as is, and then we add the first component as is, e to the sine cubed of 2x squared, times the derivative of the second component. And so really to find this derivative, we need only calculate the derivative of the first component and the derivative of the second component separately. So first we calculate the derivative of e to the sine cubed of 2x squared. And of course to do that you will need to use the chain rule. So the first u substitution you may want to use, or the inner component of this function, would be sine cubed of 2x squared. If you let sine cubed 2x squared be your u, then this becomes taking the derivative of e to the u, which is of course e to that u. U being the sine cubed of 2x squared. And then incorporating chain rule always requires you take the derivative of u. U being again sine cubed of 2x squared. So we take the derivative of that. And to do such, we have to use the chain rule again. To take the derivative of sine cubed of 2x squared, you can choose u to be sine of 2x squared, and then this just becomes the derivative of u cubed, which is of course 3u squared. U being sine of 2x squared, so that's what gets squared. And of course, by using chain rule, you then have to take the derivative of sine of 2x squared. Next, to find the derivative of sine of 2x squared, you again need to use chain rule. So we're going to let u be our 2x squared, and then we take the derivative of sine of u, which is of course cosine of u. And since we use chain rule, we have to multiply by the derivative of u. So 2x squared derivative. And the derivative of 2x squared is of course 4x. I'm going to clean this up a little bit. This will be 12x e to the sine cubed of 2x squared sine squared of 2x squared cosine of 2x squared. And there's our first derivative. Next, we need to find the derivative of secant cubed of 2x squared. Because remember, that was our second component of our original function f. So to do this, again, you can use chain rule. Letting u be secant of 2x squared, this just becomes taking the derivative of u cubed, which is going to be 3u squared. U being secant of 2x squared, so this is 3 secant squared of 2x squared. And then, of course, you have to multiply by the derivative of u. So this is the derivative of secant 2x squared. Then to take the derivative of secant 2x squared, use the chain rule again. Let 2x squared be your u, so then you're taking the derivative of secant of u. The derivative of secant is sine over cosine squared. You can also write that as sine secant squared, and that's what I'm going to do. And then, of course, since you use chain rule, multiply by the derivative of what you chose to be your u. So the derivative of 2x squared, which is, of course, 4x. And if you clean this up a little bit, you get 12x secant to the 4th of 2x squared sine 2x squared. And so now that we have both components of what we need to use the product rule, it's just a matter of plugging them into the product rule formula and simplifying what we can. So recall, when using chain rule, we're going to put what we calculate to be the derivative of e to the sine cubed to 2x squared and multiply that by secant cubed to 2x squared. Then we're going to add e sine cubed 2x squared times what we found to be the derivative of secant cubed of 2x squared. So what we found to be the derivative of e to the power of sine cubed to 2x squared was 12x e to the sine cubed of 2x squared times sine squared of 2x squared times cosine of 2x squared. And then we're going to multiply this by, remember, secant cubed to 2x squared. That was the part of the original function that we didn't take the derivative of for that part. Then we have to add to this e to the sine cubed 2x squared as is, and then we're going to multiply this by what we found to be the derivative of secant cubed to 2x squared, which turned out to be 12x secant to the 4th of 2x squared sine of 2x squared. Okay. And so this is actually our derivative of f. What we need to do is simplify this as much as we can, because you have two terms here, and you can factor out 12x from both, and you can also factor out e sine cubed to 2x squared from both. And so factoring these out, we find that the derivative of f of x is equal to 12x e to the power of sine cubed of 2x squared times, and what we have left is sine squared of 2x squared times cosine of 2x squared times secant cubed of 2x squared. So what we notice with secant is that secant is 1 over cosine. So when you multiply cosine times 1 over cosine cubed, you end up with 1 over cosine squared, because one of the cosines cancels out, which is, of course, secant squared of 2x squared. So that's what is left there. And then you can move on to your second term, which is just secant to the 4th of 2x squared times sine of 2x squared. And there's your derivative of f of x. I hope this was helpful to you, and hope you have a good day, and I'll see you in the next one. Take care.